Okay, everyone, good morning. I propose we get started. I can see that people are still logging in, but I don't think that needs to be an inhibitor to us getting started on this morning's session. We have quite a lot of stuff to get through. So my name's Tom Phillis, and I work in the European Commission's Director General for Informatics, DIGIT, and I'd like to welcome you all to today's live webinar on E-ARK validation. And I'd like to note right at the outset that today's content is especially interesting or useful for those of you who may have applied for CEF funding to cover the costs of implementing the Connecting Europe Facility CEF eArchiving building block. But it is also, of course, useful beyond just that. Very quickly, some ground rules for today's webinar before we get on to the content. So when you join, please click on Connect Audio. It appears in a green button to hear the presenters, but please make sure your microphone is muted throughout the webinar. We will mute anyone who is unmuted, but we do ask if you can try and make sure you are consistently muted throughout the presentations. For the chat and discussion, you will see that there is a chat function in WebEx. If you click on the speech bubble, the little round bubble symbol at the bottom of the page, you'll see a little chat window appears, and you can post your questions in there. You're welcome to post your questions to the presenters as we go forward, but we do also have time for a sort of an overall Q&A at the end. So, I mean, if it's possible, save your questions maybe for the Q&A discussion, but if you really don't understand something or really have a burning question related to some specific content, then please do use the chat as you need, and especially if you have audio trouble or anything like this, and then a member of the team will help you. And please note that this webinar is recorded as per the privacy statement in the registration form, and we will post the recording of this webinar on the CEF Digital site. Okay, and today's discussions should go through till about 11:30. So if we can go through to the next slide, we'll have a quick look at today's agenda. Can I move the slide? Pavel, can we move the slide forward? Because I think you have control of the overall deck. Hello? Pavel, you should have control of the... Okay, sorry about that. Yeah, one of our colleagues' computer froze. Let me quickly upload and share the contents. Does everyone see my presentation? Can someone maybe just chip in my audio?
Yes.
Yeah, brilliant. Okay, no problem, Pavel. Sorry, his computer froze, so we couldn't go through the slides. No problem. Okie dokie. So voilà, today's agenda. So there'll be a short welcome on the CEF program more widely for those of you who are not familiar with it. That'll be by myself. We then have a welcome note on the eArchiving building block by Dr. Jamie Kaminski and the training activities upcoming. And then we have today's main presentation by Carl Wilson from the Open Preservation Foundation and Kostas Simatos, also from DG Digit. And then we have a Q&A session. So plenty to get through. So without much ado, I'm going to give a very quick overview of the CEF program. I think many of you have joined our previous webinars, but it's just nice to make sure everyone's on the same page. So the Connecting Europe Facility is the European Union's largest financial instrument for cross-border infrastructure funding. And this is therefore different to H2020. It's not a research and development financing mechanism. It is very much targeted at cross-border infrastructure. CEF is governed through a specific regulation which covers different areas: transport, energy, and telecom. And through the CEF Telecom guidelines, the strategic provisions outlined for how CEF funding can be used in the area of telecommunications, and this includes digital infrastructure, which means the promotion of reusable digital solutions based on open standards that interconnect national IT landscapes. And these are governed further by our annual work programs, and you will find links in the presentation to these various documents, which are quite informative if you want to understand a bit more detail about the work we're doing. CEF comes to an end as a program in its current form next year, and our work will be will move forward in the form of the Digital Europe program, and you can find more information on that on our website, which you'll see on the last slide of this presentation. Voilà, a quick overview of the building blocks which are supported through CEF. We have big data test infrastructure, which provides a secure standards-based sandbox to experiment with big data. Context Broker allows you to analyze and manage data in right time or near real time with the creation of smart apps. eArchiving we'll discuss in some detail today, obviously. The European Blockchain Services infrastructure is creating a public sector-led blockchain infrastructure at the European level. The e-invoicing building block supports the promotion of the European standard on e-invoicing in public procurement and the wider digitalization of public procurement. EID supports the interconnection of national electronic ID systems in Europe, ID schemes in Europe, meaning you can use your Belgian ID to log into a German or Swedish or Portuguese public service and soon private service. E-delivery supports the secure exchange of data across borders. E-signature supports the creation of electronic signatures in line with the relevant EU legislation. And finally, e-translation provides a secure and secure translation service, which can also be integrated into websites and which allows you to keep the intellectual property rights of the text that translated. It isn't owned by anyone else, as might be the case with other translation services. So when we're talking about building blocks, this is what we're talking about. Each building block has a specific and bespoke set of services, but they all follow a sort of common theme. These services are free and typically include training sessions on how to get started implementing one of these building blocks, a sample software, again based on open standards, and testing and conformance testing services. And some building blocks may have other services, etc., but I think these are the core kind of services you will find provided. How do you use a building block? So you can basically build, buy, or reuse, and co-develop a solution together with a partner or other parties. So you can build a solution from scratch because all of these building blocks are fundamentally based on common standards and packages of standards. You could buy a compliant solution on the market. So these are solutions that have already implemented these standards and have obviously marketized these solutions, or you can take the sample software from CEF Digital. Again, this changes slightly from building block to building block, but it's a broad idea. And the key thing to understand is that all these things are based on common standards. Okay, without further ado, I'll hand over to Jamie Kaminsky. So Jamie, please.
Thank you, Tom, as always, for that really useful introduction to the building blocks. As Tom mentioned, I'm head of training for the eArchiving building block. I'd like to extend my welcome to you today in what is the 7th of our training webinars. It's good to see so many of our regular listeners with us today, so to everybody. Next slide, please. So, as always, I will say a few words about the eArchiving building block. Apologies to our regular listeners who might have heard this a few times before. But the building block, the eArchiving building block, was created in late 2018. And it provides a set of specifications and tools for transmitting, describing, and preserving digital data. And you can find all of this information on the building block website. See the URL on the screen now, but I just want to say a lot of work has gone into the website over the summer months. I'm pleased to say that we just unveiled the new look site. So please have a look. There's lots of new content, an improved layout, and it's looking really good. So do have a look at that. I'm going to put a link, I'm going to post a link in the chat box later after I finish speaking. Next slide, please. So, what do we do? Well, we provide a variety of the archiving services. So, we maintain technical specifications. In our particular case, the core specification is the common specification for information packages. We did our first webinar, training webinar on this in February. But we've also got specific content information type specifications that we manage and maintain. We also provide open source tools that you can download and use right away. We have compliance and validation tools to ensure that specifications are followed, and that's what we're going to be looking at today. We've got a service desk. We're developing a training offer, of which this is part, and we have outreach and community engagement activities, of which this is also part. And all of this revolves around data preservation, reuse, migration, and trust. Next slide, please. So today's webinar is part of the building blocks that we are training offer. I always say our training is based on actual user requirements, because we pride ourselves on listening to what the community has to say. Next slide, please. So many of you, I know, have completed our user needs survey earlier in the year, and the results have been really helpful for us. We can even go so far as to compare the responses from this year with the survey we conducted in 2018 and begin to see trends that goes through. So thank you all who responded to that. We've taken note of what you've said, and we will try to implement as much as we can. Now, although we've completed the user needs survey, I'd just like to direct your attention to a short satisfaction survey that will be running for this and future webinars. It's only about 6 questions long, take much of your time, but it would be really helpful for us to really understand, are we getting this right? Are there things that we think right? Is there anything that doesn't work? And most importantly, is there anything that you'd like to see us include in the future? So again, this is a chance for you to influence what we do. And we do listen. We do review the data that comes in every couple of weeks.
Jamie?
Yes?
Would it be possible for you to get closer to your mic?
Okay, I'll see if I can fiddle with the volume. Is that helping?
Perfect.
Okay. Okay, next slide, please. So, in terms of the core training that we are going to deliver, it's going to be delivered in the form of webinars like this one. It will be in the form of videos like those on the YouTube channel, and training modules in the new platform. And the content will include things like the core specification, the key content information type specifications, like those for the database, like CEF, and the geospatial data. We're also going to look at end-to-end e-archiving systems, such as Loader, which we covered in June, and the SSR, which we covered in March. We're going to look at validation and compliance, which we're going to begin to look at today. And we'll look at e-ARK web and a lot more. Next slide, please. So, as Tom said earlier, the webinars will be recorded and made available on the CEF eArchiving webinar page, which you can see a screenshot here. And on this page, you've got access to the PDF of the slide deck and a recording of the webinar itself. If you look at the far right-hand column, you can see a link to the answers to the questions that were asked at the webinar. So, you ask any questions today? they'll be made available anonymously, of course, in this format. Slide, please. Alternatively, you can visit the CEF YouTube channel directly to look at the recordings. Now, the YouTube channel is a really useful resource in its own right. There's additional e-archiving content and material from the other building blocks that Tom talked about earlier. So again, do take a look at this. It is a really fantastic resource. Next slide, please. So, as I said earlier, our webinars are part of a broader range of outreach activity that include things like workshops at conferences and other such activities. Now, obviously, with the current pandemic, there are very few face-to-face conferences going on. But as soon as they return, so will we. In the meantime, we're doing what we can to attend online conferences. In terms of other outreach activities, we've also got a LinkedIn group. See the link on the screen there, a Twitter handle. So please sign up to the social media if you have done so. Next slide, please. So before I hand over to our main speakers today, I just want to remind you about the next webinar, which will be on Thursday, November the 26th. When we'll be looking at the e-ARK web user interface. This session will be led by Sven Schwab from the Austrian Institute of Technology. That will close our autumn season. So now it's just my final job to introduce our speakers for today. So as you can see from the timetable, we've got two speakers. We've got Carl Wilson, who is the technical lead Open Preservation Foundation, and Kostas Samatos from Digit. And together, they're going to introduce us to the e-ARK validation procedures. So, Carl, over to
you. Thanks, Jamie. I'm just going to check the quality of my audio. Is that clear enough? Do people hear me? Okay, yes. Okay, thanks very much. Okay, could I have the first slide, please? Yeah, hi. We're here to talk about, Kostas and myself are here to talk about e-ARK validation. Next slide, please. Now, I'll say a little bit about ourselves. And yeah, we'll just be talking a little about what e-ARK validation software is, describing some of the software components and looking at how they might help yourselves and your organizations. Next slide, please. A little word about the two presenters. My name's Carl Wilson. I'm the technical lead at the Open Preservation Foundation, and we champion and maintain and develop open source solutions for use in the digital preservation domain. I'm also the e-ARK validation activity lead. My co-presenter is Kostas Samatos, who's the solution architect at Digit, and he's head of the technical lead at interoperability at the testbed, the CEF testbed. Next slide, please. Okay, to start, I'm going to put a few concepts into place. You'll hear three terms talked about at times today: validation, conformance, and compliance. We'll be looking at an e-ARK validator, and that provides instant validation answers. And in this case, we look at validation as the logical yes/no result of a test of an information package. I will cover some of these concepts a little later in the presentation, of an information package against a set of structural tests, schema validation tests, and Schematron rules. But really what validation gives you is a straightforward answer of, is this information package valid or not? We then talk about conformance. Well, conformance is the demonstration of valid IPs at various points in a digital archiving life cycle. So it may be that you validate a submission package before it's entered to the archive. You would validate an archival package actually within the archive, and it's validating at different points in the life cycle and ensuring that these test scenarios are valid and hold true. That's what we're talking about with conformance. And compliance is when a digital archive demonstrates evidence of conformance across its life cycle. Next slide, please. Okay, so the purpose of today's webinar is first, put information package validation in the context of digital archiving lifecycle. So we'll have a look at what information packages are and discuss the lifecycle of information packages through a digital archive and how validation can help at those stages. We will then have a look at eArk's three-stage validation process for information packages. So we have a layered validation model, and we'll cover that in a little bit of detail, but not deep technical detail. Then we'll discuss the capabilities of the eArk validation software and the components. You'll then learn how to use the online validators. There'll be a quick demonstration of 2 validator instances, which we'll describe as we come to them. And then hopefully we'll get some idea of how you might use some of the eArk validation tools in your organization. And finally, we'll discuss what our plans are for conformance testing and validation in the next year of the project. Next slide, please. Okay, I'm not going to go into too much detail here, but we'll talk a lot about information packages. And these are information packages as defined by OAIS. OAIS is an ever-present conceptual model within digital preservation. Many archives claim OAIS compliance. It is a large, fairly detailed conceptual model, and it covers an awful lot of ground, but we're having a look here at just information packages. And actually, at some level, an information package can be looked at as a fairly simple gathering of content information, and that content information is literally the digital or physical objects that you are trying to preserve over time, and a bunch of representation information that gives some kind of presenting system an idea of how to render the technical information needed to render those objects. And then accompanying that, there's a bunch of preservation description information. This is just different metadata of the type anyone who works in libraries and archives is used to. We have reference information, provenance, the history of the item, fixed information, I checksum, so we know the item hasn't been corrupted, but these are quite common concepts. So really, an information package brings together the content information and the preservation description information, and as a complete unit for long-term preservation. Next slide, please. And then finally, OAIS here divides information packages up into 3 types, and these 3 types really represent information over the digital over the information package lifecycle. A submission information package is simply an information package that's been submitted by some kind of producer to an archive for long-term archiving and storage. Archival information package is basically the transform SIP. This is the package that's preserved in perpetuity by the archive, and it needs to contain both the content and all the representation information and metadata required for long-term preservation. And finally, a dissemination information package is the package that's sent from an archive to some kind of consumer. Somebody asks for information from the archive, and they receive a dissemination information package, which will be based upon the contents of one or more archival information packages. And that information package may contain archival surrogates for some of the high quality originals. It may contain less information because of security or GDPR. There may be various things that are done to a package before it's disseminated out. Those three package states represent those points in the information lifecycle. Next slide, please. So now we're going to take a look at information packages within eArk. So OAIS very loosely defines what could and should what could be in an information package, but really says very little about what should be in there or how the information in that package is arranged. So it is very much a conceptual model, but there is little guide for implementers in terms of real details. It's meant to be a general model that's applicable to a wide range of scenarios, but that means there's very little in the way of really detailed information as to what goes inside an information package. And there's no basis really for interoperability between different OIS implementations, because information packages from different systems don't need to have any common ground, very little common ground. They may support the concepts, but the implementation may be entirely different. So E-ARK basically sets out to address these issues by defining a formal, logical, and physical structure for information packages. We'll say a little bit more about logical and physical structure as we go. Next slide, please. So E-ARK has specifications for 3 information packages, and in some ways 4 specifications. I will talk a little bit about them one at a time. So we have actually produced machine validatable specifications for submission information packages and dissemination information packages. And at the moment, those machine validatable specifications are actually published in 3 parts. There is the common specification for information packages, the CEF. That basically contains about 140 rules, in fact, more than 150, including the structural rules now, that apply to all information packages. So that's the common rule set between the CIPs and the DIPs. Then there are a bunch of specialist rules for submission information packages and another set of specialist rules for disseminating information packages. These are layered upon on top of the common information and the common specification, sorry. The odd package type out here is archival information package. That's simply because that's generally implemented by developers of archival systems. And the structure on the disk, etc., tends to be a function of the archival system rather than some specification. We're reviewing our approach to the AIP in the second year of the project, and we have some ideas as to something that may be actually validatable there. But at the moment, validation is really on CIPs and DIPs, and a lot of the common specification, common rules are from the CSIP. Next slide, please. So IP validation, there is a life cycle, and information package validation, we feel, has utility across the entire life cycle of an information package. Ideally, people who create submissions, so these are the people who submit information to the archive, to an archive. For national archives, that may well be other government agencies. For libraries, it will be publishers and newspapers. But these are people who create information and then submit to an archive. Now, ideally, validation will take place at creation by the producer and at submission to the archive. But E-ARK intends to provide a common tool set that's open source, and that can be used both at creation by the producer, so that when it comes to the archive, validation at the archive should be just a repeat of the validation done by the producer. So you should be really just confirming the results of production. But the ability to share the same set of software and rule sets across producer and the archive at the archive end for free buys you some utility there. Again, validation at AIP creation by the archive. So this is when you've taken the submission information package and run probably other tasks over it. Some of those might be validation tasks. They may be tasks that extract technical or descriptive metadata and put them within the package. But again, once that AIP is created and ready for long-term archiving, validation should occur again then. There are probably opportunities to revalidate AIPs as they're transformed by an archive over their life cycle. This could be anything from adding new metadata because better tools are available, to having to break large packages up for various reasons. But at those points of transformation, when you create new AIPs, you can again validate them. And then finally at DIP creation by the archive. So when you create a package to send to a consumer on request, it gives you a set of tools where you can validate that package and assure you're sending out a valid package. Next slide, please. So the E-ARK validation, we are following what we call a 3-phase model, and there are 3 logical phases to validation. The first is what we call the structural phase. We validate structure. And there are basically 16 rules to ensure that the package structure is valid. And at the moment, this covers the presence of specific directories that we prescribe and a main metadata file. One word about the metadata file at the moment. Our implementation for eArch is METS-based. So it expects to find metadata, a METS metadata file in the root of a package. In theory, the ideas and the specifications could be implemented in without METS. So the idea is that the specification should be shouldn't rely on METS for implementation, but at the moment METS is our main source of implementation, and we're unaware of a better metadata schema at the moment. So following the structural validation, where it establishes that you have the correct files and directories in the right place, it then performs metadata validation. So first, this is just schema validation of the metadata files, and then we run an extended set of metadata checks, which is currently around 150 rules. These are implemented as Schematron, and we'll have a look at those a little later. And then finally, integrity checking. If the structure and metadata is deemed valid, the final integrity checks run across, basically ensuring that every file that's listed in the METS documents is present on the file system. The checksums for those files are valid if they're presented by the in the metadata. And finally, there are no orphan files. And by orphan, we mean files that exist on the file system and there is no reference to them in any metadata file. That is viewed as a mistake. Next slide, please. So here we'll just have a quick look at the standard structure of an eArch information package. It has a root folder at the top, information package that would normally be named according to the ID of the information package. Within there, you have a root metadata folder that can hold subfolders for different types of metadata, descriptive, preservation, or other. A representations folder, which would hold different representations of the item that has been preserved. These might be a PDF and an Excel version of data tables. It could be a database and a CR version of the database. And that kind of idea of different representations, and each of those has their own data and metadata. And then we allow further top-level directories, some to hold schemas necessary that are used by some of the metadata files within other places in the package. So schemas allow a package to be self-contained and contain all its own schema files that are required for validation. Documentation for any miscellaneous documentation, usually about the package or the collection it belongs to. And then we do allow other subfolders at the top. And next slide, please. So next stage is the validation of metadata, and metadata validation covers the validation of the XML METS files against the METS schema. This is the METS files for both the top-level package and the representations. Additional validation against eArch extension schema, and these are separate from the Schematron rules. These are further XML schema that cover a set of extended attributes defined by the eArch project. And then finally, validation against the extended rule set. And this rule set is considerably more prescriptive than METS schema. The METS schema is actually very relaxed. A valid METS document can contain very little beyond the structure map and one or two elements. But yeah, a valid METS document can be extremely minimal, and we make a lot more stipulations than the standard METS schema. And these Schematron rules are actually published as a METS profile that's available from the specification sites, which is a METS profile is an XML document that describes the rules, but it's not quite machine enforceable. We've taken those rules and developed a set of Schematron rules, which you can run over a METS file, and they enforce the rules that are in the METS profile. We'll have a look at the sites that cover this briefly when we look at the validator demonstration. Next slide, please. Okay, and then the final stage is integrity checking. And integrity checking, as I said before, ensures that all the files listed in the metadata documents are present on the file system in the package. So yeah, every reference within any METS file will be checked. If the checksums available in the METS file, they will be validated, first if they're present, and B, we make this an optional step, because for large packages, this can be incredibly time consuming. Yeah, if you've got hundreds of megabytes of data, the checksumming phase just takes an awful long time. So it is an optional step. And then finally, we ensure that there are no orphaned files in the package. And the 3 rules for an orphan file is a file that is not so the rule for an orphan file is a file that is present on the file system and not referenced within the metadata METS file anywhere. And basically, we believe that means it's possible that the file does not belong in the package, or that it does belong in the package and the metadata has been omitted. Next slide, please. So finally, we are currently defining what we call content information type specifications. And this is a step beyond the current information package validation, because information package validation it's a great first step. As we've seen, it ensures that the package has a standard structure, that the metadata is present and valid, and the package content is present and valid. But it doesn't validate anything about the content itself. So content-specific files or content-specific files and metadata that are specific to a type of content, for instance, databases, it knows nothing about conventions or specifications at that level. So to address this, eArk's also producing what we call content information type specifications, or CITs. Next slide, please. And this is a current look of the set of CITs that are actually currently out for public review. These have been published very recently, and we're waiting feedback from public review for January. Our current sets of CITs cover things like CR databases. So this is both databases and an XML representation of the data in those databases for long-term preservation. There is a specification covering electronic records management system data. There is a specification for geospatial data. eHealth and e-invoicing are also on our radar. Now, we're not guaranteeing there will be validators for all these CITs. As the specifications are out, the A3 team are reviewing these content information type specifications for suitability for machine validation. We haven't got final decisions on any of those. They will be available by the time of the public review, because there may be feedback from there that affects our decisions. But we're fairly confident about building validators for CR certainly, and 1 or 2 of the geospatial types. But basically anywhere where we won't be writing software from the ground up, but anywhere where the community for the content type offers good validation software or schemas, we will look to hook those up into some kind of validation package. Next slide, please. Okay, so I'm going to briefly cover the validation software components. We have a validation library that we're implementing in 2 different languages. We have a Java implementation and a Python implementation. There are various reasons for having 2 implementations. One was the developers that work on the project and the some of the software suppliers that work on the project. These are by far and away the 2 most common languages. But they also give us opportunities to test one implementation against the other when we're writing a specification and the tests for that kind of thing from the ground up, producing test corpus data and different ways of testing validators against each other is basically useful for ensuring you have some kind of commonality. And there's not as much work in this as it sounds, because actually both these implementations share several common components. The METS XML schema, the extension XML schema, and actually the Schematron rules can be all implemented using standard libraries in these languages and other languages. So actually, in general, it's the specialist structural rules that need to be handcrafted in an individual language. And I suspect that when we come to really bite the bullet with them, that some of the content information types will have to be language specific as well, because of the existing toolkits and software we can use in that domain. But yeah, and these common components could actually be used by other validator implementations to guarantee large-scale conformance to our own implementation. So that would guarantee that all of the metadata, including extended metadata validation, was common across your implementation, but you would need to develop some bespoke code for 1 or 2 rules. Next slide, please. And so these are from a programmatic point of view, these are kind of the concepts we have: the Java implementation and the Python implementation. On top of those, there sits a language-specific API which would be used by developers who are developing software in either Java. So Java developers would use the Java library and API. Python developers could use the Python library and API. And you can make language-specific calls, but it's difficult to make calls across language. So it would be very difficult for a Java implementer to decide they wanted to use the Python version, the API. But we have defined on top of that is a REST wrapper for each implementation. And these implement a common REST API. And that REST API, we've done this by going REST API first. So the REST API is defined in OpenAPI version 3, which is known as Swagger. That gives you one common API definition, and then you can use that definition to generate the stubs and API code for different development environments. We've generated Java and Python versions, but actually everything from JavaScript to C# and an awful lot of, there's about 20 to 30 different languages and developing environments supported by the Swagger tool. So from the definition of the REST API, if you wanted to provide your own implementation in a different language, you could at least generate the data types and API endpoints that are required to implement. It would leave an awful lot of work to actually to put the implementation in, but the framework's there. Next slide, please. And using this REST interface, we've put up at the moment two online validation services. And we have two different versions of this. The first is the E-ARK online validator. This is our own test instance, and it's a stateless instance, and it runs synchronous validation. By that I mean you upload a package and you get a validation results instantly. And we don't save packages on the system. They're generally just put into a temp memory file system that's deleted after validation. And then we will show the CEF testbed instance. This is a second validator instance run by the EU's CEF testbed. And this is actually intended to be a testing platform for conformance testing as described earlier. So rather than simply uploading packages to validate, this provides a bit more interactive environments where users can have accounts. There will be test scenarios defined, and the results are recorded, which allow people to review and monitor the results. So yeah, this would really be for software suppliers looking to test their conformance against the E-ARK package lifecycle. So this would be the kind of scenario testing I was talking about earlier. So rather than just testing a package, it would be you test package at point A, apply operation XYZ, and test a package again after those operations and ensure that it's valid and as expected at both points. Next slide, please. So I will now hopefully give a live demonstration of this. I haven't filmed it. I'm about to share my screen.
Right, I'll just make you, you should actually be fine. Try sharing your screen. Yeah, voila.
I think I'm doing it. Does everyone see my screen?
Yeah, clear.
And it's clear, okay then. So this is E-ARK's online validator, and at the moment it's a fairly simple, as I say, fire and forget web service. I'm going to basically show you the validation of a few packages, some valid, some invalid, that demonstrate some of the concepts I talked about in terms of structure and metadata checking and some of the function of the validators. So when you're presented with this screen, you can always get back to this screen by hitting the validate menu item here. Browse, and I have a set of test data here which I've prepared, and I hope it's going to let me down. So the first thing I'm going to do is actually upload a package I know has got structural issues. So the first thing to note is when I choose the package, actually the web page JavaScript will actually calculate the package SHA-1. The reason for this is that's actually used to validate the transmission of the package. You submit the package and its SHA-1 to the web service, and the first thing it does is checks the SHA-1 of the uploaded package against the one that was submitted to ensure that the package hasn't been corrupted in transmission. Then you simply press the submit button and you get a set of results as so. This is a validation report that tells you the ID of the package, and here you can see the checks are broken up into various parts. At the moment we have the structural checks, the verdict is not well formed, and these here represent the different types of errors. Some are warnings, some are warning levels, and some are, this one is the error that's actually stopping, preventing the package from passing the structural tests. And here you get a description of the error, and here it says that the information package root folder must contain a file, a single METS file named METS.xml. And this is actually the metadata file that drives the rest of the package. So we need somewhere to bootstrap passing of a package, and that's the main rule, that the root folder must contain a METS.xml file. And if you want more details about the error, you can simply, probably shouldn't do that slightly differently so I don't get lost. I'll open that link in a new tab, and that will take you to the eArch's specification site, and takes you to the particular error. So here you can actually see the error message in context and read the specification rules around there to give you a better idea of what may have gone wrong and how you may fix this. And in this case, the fix is quite simple. It needs a file called METS.xml within the root folder. I'm just going to see, can people see my screen now, a different screen when I'm looking at the, do you see that, or do you still see my browser? Oh, I can see it, you can see this. Okay then, so here I can actually just have a look at that package, and you can see here actually it has a file called METS.xml, but the naming is case sensitive. So it's the lack of an uppercase METS file. These are one of the many test scenarios that we have. So the number here is the rule that's under test, and number 1 means this is one particular bad test for that scenario. Missing file altogether, different casing, deceptive names. I mean, I think we maybe have 15 tests for this individual case test for this rule. Okay, I'll try to demonstrate one next level of validation. So back to the validator here. In this case, I'm going to pick a package that I know is got the correct structure, but I know that the METS file is invalid because I've corrupted it deliberately. Again, when you pick it, it calculates the SHA-1 of the file. And here you see we only have 3 warnings. So structurally, it's actually passed and the checks are well formed. I now actually see when I'm demonstrating it, I'm not a user as well, and we've had limited user feedback. There's a badge here to say that it was well formed. If that was red or green, that would be useful. Going down further into the check, so you can see here that schema validation has failed and it's logged as invalid. And the main error here is the element is not expected. It expects a name element and not name Z. And hopefully, if I open that package here, open the METS file here, you can see here we have the invalid element that I've corrupted the name of. But again, the idea is the rules will help you. And here there is no link back because the schema rules are entirely these are entirely based on the METS schema. So we haven't written individual rules for that. This is basically METS schema validation. So that's the first stage of metadata checking. I'm now going to show another stage of metadata checking. So this is a package with no creation date. So it's missing a mandatory field. This will pass schema validation, but it will fail on the Schematron check. So that's the plan. So here we have the results of submitting that package again. The package is judged well formed. Again, there's just a set of warnings. These are recommendations you're seeing here that there should always be, that each representation should have its own METS file, that a representation folder should include a metadata folder, which may include extra metadata about the representation. So yeah, warnings, but these are still valid. The package is still valid structurally. At this level, schema validation is checked here, but now you can start to look down, and these are the Schematron validation, and the results here are actually broken down by METS, the main METS sections, once again to help you work out which part of the package is invalid. So here you can see that the METS roots considered valid, headers considered invalid, the file sections considered invalid, and the structural maps considered invalid. And again here you can get a list of the errors that you've encountered, some more contextual information to tell you what the error is, and a namespace, but not particularly friendly. These errors are the ones that come back from the Schematron engine. We're working on cleaning those up at the moment, so they're a little bit more user-friendly. And in a system where we retain the data, remember, we don't retain the data at this end because it's someone else, it's other people's data. We don't want to live with uploaded data on our system. It's very difficult to show these errors in line in the METS documents because we just don't retain them. But a CEF system, for instance, where there's logon and a bit more protection for user data, that might be possible. So here we've got a bunch of warnings, but you can see here the first validation error is this one here, which says the METS header must have a create data attribute. And if I hit the link here, it will take you to the right section of the specification. And again, there's a bit more contextual information about the errors in line in that document. And it's a little easier to read. To go back to here, I will just pull that package again here. So if I go into create date here, open the METS file, and you can see here that just wait there. So this is at the error is in the METS header, and you can see here that if I go to the METS header, there indeed is no creation date with attribute within there. These, just for information, this kind of CSIPs namespace stuff, these are the extensions, the eArch extension schema I was talking about. So these are additional attributes that are namespaced under the eArch namespace. Okay. And finally, my last demonstration, if all goes well, will be a valid package. So here's what a valid package, which admittedly still has a few warnings, looks like. Sorry, I need to go back a page. Back to the validation page. Final package. And here we have minimum valid IP with schemas. And if I submit that to the validator here, you can see that finally I get a well-formed message here. The same three warnings about folders that we may want to use but aren't prescribed, schema validation passes, and all the 6 stages of metadata Schematron validation package. There is still a few warnings. Once again, these are recommendations, but the package is not considered invalid. These are ideas that, for instance, maybe the METS header should have a last modified date. That maybe there should be a label for representations in one of the divs. But these are recommendations. You can still look them up on inline, but they're not hard, fast rules, so the package is considered valid. And there ends the demonstration. I'll stop sharing my screen and hopefully back to the slides and next slide.
Well, Carl, that was excellent. Thank you very much. We'll just get the slides up.
Okay.
And then, so we move on to our next and final speaker. So that is Kostas. Kostas, please, the floor is yours.
Yes, thank you, Tom. Thank you, Carl, for the presentation up to now. Can you first confirm that you can hear me clear enough?
Yeah.
Okay, great. Just checking the audio, just to be sure. So yes, greetings to everyone. My name is Kostas Matos. I'm a solution architect with Digit, as we mentioned before, and I'm the technical leader of the interoperability testbed action at the European Commission's Digit. So I'm going to talk to you today about how we're going to approach conformance testing for eArchiving. And as Carl mentioned before, this is basically it's a flip side over the more standalone validation that the validator brings. For the conformance testing, the focus is really on testing conformance to the specifications following specific scenarios. For the conformance testing solution, eArchiving is going to use the interoperability testbed. This is an online service that is offered through the ISA program, and specifically the ISA unit from Digit. It's an online platform, as I said, that is offered for the conformance testing of software against specifications. One thing that is very important to note here is that this environment, this platform, it's self-service. So once this has been set up by the archiving administrators, basically, so the different scenarios to be tested for have been set up, users can use this self-service. You do not need to I mean, if you want to be testing to validate, for example, your funding applications, your grant applications, you do not need to coordinate necessarily beforehand to technically set up your test environment. You can simply proceed, use the environment, proceed with testing, repeat testing if you have initial failures, for example. And once you're ready, then the administrators of the community, as it's called, are going to be able to verify verify and assert your conformance. So specifically now for eArchiving, as I said, we're going to be defining scenarios. This is what is going to add value over the simple standalone validation. And these different scenarios, they can be, as Carl mentioned, quite varied. So these have not been defined yet. The current setup is quite limited, as you're going to see. But the different scenarios that we envisage involve, for example, testing in different contexts. So, for example, testing for specific data or producing specific archives that are expected to include certain information or not. Handling, for example, archives both as a producer and also as a consumer of archives, handling also error cases. So what happens when you receive an archive that is actually malformed, that contains actually errors, but also potentially the exchange of archives using different channels. So currently, the current setup that I'm going to demonstrate for you afterwards, it is simple. So it basically just expects a user to upload an archive for validation. But this then could be expanded to using channels such as e-delivery. So if you want to have packages transferred automatically through e-delivery, this could be something that the testbed could capture through specific scenarios where it would act as as an access point receiving such packages to process them. As part of these scenarios, validation is a key point. So this is why the eArch validator that Carl just presented, it's reused actually in the conformance testing scenarios as a building block. So the REST API that Carl talked about, this is the API that the testbed uses through its test scenarios. So we add all of the context around in these scenarios, and within the specific scenarios, when we come to validating the actual exchange packages, this is done using the validator. So last point here before I go on with the demonstration is that, as I said, the current setup, it's a first initial, as we'd call it, a minimum viable product. So it basically replicates the validation that Carl showed. But as I said, keep in mind, this is planned for further extension in the future to really set up the conformance testing strategy as it's supposed to be. So having said this introduction, I'm now going to share my screen and show you what the environment looks like. Okay, so you should be seeing my my screen right now. Could you please confirm?
Come through clearly.
Okay, great. So what I'm seeing here, it's basically the homepage, the welcome page of the testbed platform. This is an environment that is currently, as I said, online, and something also that I didn't note before. This is an environment that is also shared with other CEF building blocks, specifically CEF e-invoicing. This doesn't make a difference for eArchiving. It's the same environment that is basically managed by the same operational staff. And the community, as it's called for eArchiving, it's an isolated community. So basically, it's isolated from other users. So I'm going to show you here what would be the flow when first connecting to the environment. So on this welcome page, you basically have a button here to log in. This is if you already have an account with the testbed. Otherwise, what you would do, you can optionally be assigned an account by an administrator, in which case you would click this link here to confirm this role assignment. Or what we're going to do now, if you're a completely new user, you can register in a public community. And in this case, you're going to be presented with the communities available in the environment, one of which is eArchiving. Now, the only thing to really note before you proceed is that to use this service, you need to have an EU login account. So EU login, it's an authentication service, an identity management service that is offered by the Commission for use by institutions and EU organizations and so forth. It is something that anyone can create. Just a quick note here, I'm not going to go into this now, but if you're new to eLogin, there is also a link to a tutorial here on how to set up an account and use it to connect to the testbed. So I'm going to click here on the link to register in a public community. So what's happening here, I'm getting redirected to eLogin. I'm already authenticated in eLogin, so I don't have to authenticate again. So it's using the eLogin SSO. And what I see here on the screen, it's the list of currently available public communities in this testbed instance, one of which, as I said, is the CEF eArchiving community. So I'm going to click here, the community link. And here I'm requested to provide information that the administrators of the community have requested from me. And here it's quite simple. I just need to provide the name, a short and full name for my organization. So this is the party that is going to be testing for conformance. I'm just going to add some sample information. Now here, it could be the case that once the environment is further elaborated, we're going to see additional information requested, such as additional details. For example, in the case of electronic invoicing, here we request the ENIA numbers that link to the claims for funding and so forth. But currently it's quite simple. And last point here to note that you see here there's a configuration option. This is a set of, let's say, curated conformance testing configuration setups that the administrators have prepared. And the idea is basically that once you connect, once you register, you're already connected to all the different things that you need to test for. Here currently there is one such option that is required, and as it's one, it's pre-selected, which is archive provider. So basically the role of an organization that is going to be building and producing and providing such archives. So I'm going to click on complete. So once I've done this, I see here the list of the roles that I have on the testbed. I'm a special case because, of course, I have administrator access in the different communities. But for a new user, they would basically just see one entry here, which afterwards, once you disconnect and re-log in on all of your subsequent sessions, you will be automatically connected through this. So you're not going to have to select your role every time you connect. So now here to demonstrate the use, I'm going to click here on the role that I just created. And what I come to here is the landing page, as we call it, for the CEF eArchiving community in the testbed. This is basically, it's a welcome message. It provides links to the specification, to the standards. Also, we provide a link to the validator. There is currently also a link to some sample packages that can be used just for testing. This is something that the administrators of the community here, of the archiving community, can adapt basically as testing proceeds. So this is really just a landing page. From here, I'm not going to go into all the details, but you have a link to a user guide, which I'm just going to show you quick. It's quite thorough. So anything you want to do on the testbed, through this user guide, you can get the full information how to do it. This you would get through the user guide link. You can contact the support help desk through here, through this link, where you would get a pop-up where you provide your message, any attachments and stuff. Okay, your basic contact support feature. Legal information here about data retentions and so forth. And I think from this point on, we can move into actually proceed with testing. So to do this, I'm going to click on the tests link here. Now here what I see is a system, which is basically, it's like a logical entity that is used within the testbed for what is actually claiming conformance. This is something that has been automatically created for me through this self-registration process that I did earlier. So I'm going to select it in order to proceed. And what I come to here is the list of conformance statements for this specific system. So my conformance statements. Now the concept of a conformance statement is key because it is basically what links myself as someone that wants to test for conformance, or my software basically, to one or more specifications. Currently, we have only one. We have one, let's say, global common specification for information packages. But this here could be actually more fine-grained. You could have, if this is what we choose to do for the conformance testing, this could be split up into different profiles. For example, you could have profiles for the SIP, the DIP, the AIP packages, for example. And also you could have different actors. So here you see the actor, the role basically that you are playing in the specification that you want to test for in this specification. In this case, it's archive provider. Recall this is what we selected in the first screen. But it could be the case that you want to be testing as a consumer, for example. And there would be then a different conformance testing process for this. Currently, there is only one entry because we just have, I said, one specification and one actor. You see here the status. We basically have one test case that we need to pass, and currently we have not tested anything. So I'm going to click this to proceed with the testing. Here you see the details of the conformance statement. So you see what it is you're actually testing against. So a brief description of the domain, as we call it, the specification, the role you're playing, and a brief overview of your current testing status. And here you see the list of tests that need to be passed. As I said, this is probably the most bare bones basic scenario you can see. You only have one test here, when in fact you could have multiple tests and potentially also multiple tests grouped together into multiple test suites. So this is really the most basic case. We see the name of an identifier for the test case, a brief description, but also here if you want to have more information, you can click either on the overall documentation icon here, which gives you some additional context about what it is you're supposed to be testing for. So this gives you some background on what it means to conform to the specification, some details and references for the specification you're aiming for. And for the specific test case, there is also additional documentation that gives you a bit more context in terms of what it is you're going to be expected to do. So it lists here some prerequisites that you need to follow, and also the steps that you're going to realize. This is really setting the context for you to execute the test case. So to do this, you click on the play button. You also have a final point here, maybe to mention, you have an option to do this interactively or to run it in the background. Background means that if this was fully automated and you had automated exchanges between systems, this could be something we would do here. But in our case, as we're going to be uploading the archive, we're going to opt for an interactive execution. I'll click here the play icon to launch the test. So what happens here, I see here the list of test cases that I'm executing. So currently there's only one, but if I had, for example, a full test suite that I was executing, I would have here a sequence of test cases. I see the same kind of documentation here that gives me additional context. And here I see a diagram that graphically displays for me the steps that I need to make. So as I said, this is a very basic scenario, and it simply replicates now the validation that Carl showed before with the validator. We're basically going to upload the archive to validate, provide also the digest for the archive, and this is then going to be validated. And if it validates, the test case is going to succeed. Again, this is something that you wouldn't normally see in a conformance testing scenario. Here you would see normally additional checks for the specific context that you're aiming for. So checking that the data that are expected to be in the archive are there, or that the specific types of archive match the specific scenario, and so forth. But now I'm going to proceed here with a simple example. I'm going to click on the start button here. So I get the first pop-up here to provide the archive, and I have one archive I'm going to use. I'm not going to go into all the different cases like what Carl showed, because you're going to see that the output is quite similar. And here I provide also the digest. Currently, you need to provide this as a user, but this could also be calculated automatically. It's just this is the first iteration of the setup. I click on submit. And this now is passed into the validator. And you see here we have two different validation steps. One is a step, just a point, clicking on this icon here, it brings up the report of the individual steps. So clicking here, this is a step to validate the digest, and it's all good, it's success. So you see here what is the digest. You can see also the specific output from the backend validator that was actually used. Again, all of this can be tuned in the future, but it gives you an idea that you get back quite some good context on what is happening. And here on the final validation step, you see here a validation report, which looks slightly different, but is identical in content to what Carl was showing before in the standalone validator. So you see here for the archive that was validated, you see here all the different errors, warnings, and so forth, with the different codes, the tests, the locations, and so forth. basically everything that was produced from the validation of the archive. This, of course, everything you see here can be exported, so you can get PDF exports of this. I'm going to skip this for now. And this basically concludes the one test session. As I said, very simple at this stage. Now, you can go back and you can repeat the testing as much as you want. So if you have a failure, you can repeat, you can correct, you can come back and retest. And at any point in time, you can also review in this test session section here, you can review the previously completed test sessions that you have. So this is a big difference with the validator that Carl showed. The testbed is fully stateful, so anything you test with is going to be maintained as state. So here you can revisit your previous test sessions. You can bring up the same validation reports, the same data and all the different steps. You can see exactly what happened in each test scenario that was executed. All of this is maintained. And you can, of course, filter this based on different characteristics, different data, and so forth to really zero into previous test sessions. This information, I'm not going to show it now because we're also short on time, but I think it's not what would be most of interest now. All of this information and a lot more is also available to the administrators of the platform that can actually view all the test sessions that are made by organizations within the community. They can view the conformance testing status, they can issue conformance testing, conformance certificates basically, and they can basically use the environment to really monitor and follow up on the conformance testing progress of the different organizations. So I think that with this, I can complete the demo. So as I said, this is the initial version of the conformance testing environment. Expect this to be enriched in the coming months with additional scenarios, really fleshing out what needs to be tested for in each case. And also, of course, with additional documentation on processes, approach, and so forth. So I think that with this, I'm going to stop sharing now my screen and jump back, hopefully, into the presentation. I think, Tom, you can put the slide deck back up.
Yeah, can you see it now?
Yes.
Wonderful. Thanks a lot, Kostas. That was great.
Okay, and I think that's all for me. So back to you now.
Yeah, so I believe that's back on me. And this is, I think, the final slide. So I'm just going to say something about our aims for conformance and testing and validation in the next year. The slide's not as detailed as it could be. I might try and put an amended slide on the deck that we circulate. Just before I go further, I'm just going to take Janet's question in line. So Janet was asking what exactly is the SHA-1 of the package. That's actually just the SHA-1 digest checksum that's calculated across the entire zip file before it's uploaded. And the reason for doing that is it's calculated automatically on the eArch validator. I think I will just share the code with Kostas sometime soon, so that can be done automatically on the testbed instance as well. But it's basically calculated at source and then calculated again at the other end of the transmission to ensure that nothing's been corrupted in transmission. This has been important to us for testing because you don't want to be chasing errors that are caused by a transmission error rather than so yeah, it's to prevent misleading results and ensures that transmission's been done properly. And a question from Antonio I will take as well first. So are the validation reports without the GUI part of the Java, Python API or implementing the test web applications, can they be used by different? Yeah, they have native data types and the REST implementation sends those back as individual data items. It's not as if you're blasted back a piece of XML or anything. So yes, Antonio, they are genuine data types and they're serialized as JSON over the REST API. And we may even add XML support there if it's cheap and easy, i.e. if I can take a library, just flip the JSON to XML as well. But at the moment, they are JSON results returned by the REST service. Okay. So yes, I'll say a little bit now. Sorry for taking the questions in line there, but I'll say a little bit about our plans for the coming year. So I talked about the content information type specifications, which are currently out for review. As I say, we'll be reviewing them ourselves, and where possible, we will be adding validation support for those individual content types. This will probably, as I said before, this will almost certainly not be cross-language. I suspect the tools that we're using will be language specific, and there may even be, it's not entirely clear what some of the implementations might look like there. For instance, we know for the CRD and databases, there's a good Java toolkit that supports that. So it may be that becomes really supported under the Java implementation, or a set of SITs and a set of SITs REST services that could be shared with other validators. Although we are aware, again, then that transmission of databases to a web service is maybe not the best way of proceeding there, but we'll work out one or two of these details as we go. We have another version of the specification planned for late 2021, and we hope to have the validator in line for that for release, but that will be probably in the third quarter of 2021. SITS validators will be available when they're ready, but no earlier than March next year. But in the meantime, what we'll be doing is refining the validation software we have. So this is improving the REST API. We're still implementing one or two parts of a new REST API that support the four-phased validation model more explicitly. Once we do that, we will integrate that with the CEF testbed. So the steps there will actually, rather than just the SHA step and the validation step, you will get steps that support the 3 or 4 different phases of validation. We'll be looking at ways of optimizing the validation process. What actually needs to be uploaded to a service to allow it to validate. It might be possible to send just metadata and some kind of representation of the structure of a package if you're not interested in content type validation, or it's not possible to validate some of the content. So we'll be looking at one or two of those ways of optimizing these processes. And that just about concludes the presentation. I see there is one more question I will try to answer. So does conformance tests will be available for those actions selected as funding E-ARK goal? It looks like Fulgentia's has probably given a better answer to that, and I think I'll let that answer stand. So yeah, over to you for questions. One other thing is, actually we are really at the stage now where user input, user testing will help us. Whether you don't like the error messages, they're not specific enough, if we can improve the layout or parts of the process, any feedback you give us will help us make this better going forward in the next year of E-ARK. Yeah, thanks very much for your time and attention, and back over to you for questions.
Wonderful, thank you, Carl. That was excellent. Both you and Costas, I think it was really, really informative and clear. Pavel, do we have any more questions coming in from participants at the minute?
No, we do not. The last few questions were already answered.
Okay, excellent. Well, we'll give you a minute to have a think. So, so again, I'd like to thank both our presenters. You can see here the contact information, how to reach Carl, and contact the colleagues behind the E-ARK program, and you can see the general contact details for reaching us at CEF and the European Commission. We have our next webinar coming up next month, and you can register for that webinar on the same registration page that you registered to this one on. So we very much hope that we can welcome some of you back to the continuation, and I believe the last session in this series. And if we don't have any more questions, I'll allow Pavel to let me know if some arrive. Then I think we could. No, well, I think then we can call the session a couple of minutes early. So again, a big thanks to our two presenters, and a big thank you to everyone who took the time to join the session. I see Fulgencio is sharing links in the chat there. So a big thank you to everyone. The recording of this session will be published on the registration page. We'll have it up as soon as we can. And we hope to see you all again next month. Wishing you all a pleasant end to the week, and please stay safe and stay healthy. Thank you very much, and thanks Carl, and thanks Costas.
Thank you, Tom. Goodbye.